everyone, and welcome to our webinar. We're thrilled to have you join us today. My name is Miriam, and I'll be your host for this session. Today, we'll be discussing utility scale power from Solis. We'll be hearing from Igor Mogilevsky, who is the Product Solutions and Engineering Director, and Darren Bronin, the VP of Utility Sales. So, Igor, Darren, take it away.
Thanks, everybody, for joining us this afternoon to learn a little bit more about Solis inverters and how you can use a string inverter on your future utility scale projects. Just a quick background of myself. I think Igor and I bring a great background to host this conversation. I've worked for a variety of inverter companies. I've been in the industry over 10 years. Started with Satcon, was at Advanced Energy, Schneider Electric, Power Electronics, and now I'm with Solis. All central inverter suppliers. So I think with that background and what we're here to discuss today, I think I can give some insight as to why string inverters might be a good alternative. Igor, could you briefly go through your background?
Yeah, thank you, Darren. Thank you, everybody, for joining this afternoon. My name is Igor Mogilevsky. I'm Product Solution Director of Engineering for Solis. I started at Solar in 2008 with Power One. Was in charge of their entire product portfolio, including central inverters, string inverter, and microinverters. And then I was director of engineering for Sungrow, mostly working on central inverters, some storage application as well, and some string inverters as well. At the time was a new introduction on string inverters, especially for utility scale. And then I was director of engineering for utility scale for CPS. So that's my background. And now I'm with Solis and launching their utility scale solutions and the new product that we're introducing in this presentation. Thank you, everybody, again.
So as we begin, I just want to give a brief introduction of Solis and where we're coming from. This is designed to be an informative presentation, so feel free to ask questions at any time. We'd like to have open discussions about it. We do have a few slides on the company and the product, but really this is designed to be informative for you, so don't hesitate to ask us a question in the chat room, and hopefully we can answer it today. So briefly, Solis was founded in 2005. It was brought to the United States, got our first UL listing in 2009. Started out more in residential and small C&I. As the company grew in 2021, we ended up getting up to 80 gigawatts of capacity. In 2022, Solis was named the third largest inverter supplier in the world. We are also listed on Bloomberg's Tier 1 inverter suppliers. And presently now, we have operations in China and Vietnam. Just an example of the size of our company, we have 4,500 people globally. We have approximately 40 people in the United States. Within that group, we've got service and application support. So not only do we sell the inverters, we also support and service them as well. We're close to $1 billion in revenue. And as I said, we just opened up the new plant in Vietnam, which presently has 4 gigawatts of capacity and has the ability to grow depending on the requirements for the US market. The great thing about Solis is since we're relatively new in Vietnam, everything is robotics. So we're a very high-tech manufacturing facility, and we use state-of-the-art robotics for all the inverters that we manufacture.
Now I introduce some of the market, some of the product in our market where we compete, mostly CC&I market and utility market. So this is the product portfolio that we have in the CC&I market. It's a string inverter, 25 to 60 kilowatt three-phase, 480 volt AC. And then we have a 30 kilowatt three-phase, 208 volt AC for this commercial application, small commercial applications. It has a high power MPPT acceptable Y connector, compact and easy to install. It has removable AC wiring box. so you can remove the inverter and leave the AC connections in place. The next product is for commercial rooftops. It's also 75 to 125 kilowatt inverter, three-phase, 480 volts, and we're introducing this summer 60 kilowatt, three-phase to 8-volt AC. Again, a high power MPPT up to 32 amps per MPPT, wide MPPT voltage range. Both of those products are very suitable for repowering projects that we covered in another webinar in the past. The next product is large commercial small utility inverter. It's 125 kilowatt to 185 kilowatt, 600 volt AC, high current MPPT input, rugged NEMA 4X enclosure, and PLC communication in addition to Modbus communication. The next one in that family is a 255 kilowatt inverter, 800 volts. And this has also come with full skid solution, AC combiner, and medium voltage transformer. PLC communication as well to Modbus communication. And today we'll be introducing the 350 kilowatt inverter. This inverter comes in three different power variations. It has a 250 kilowatt at 600 volt AC. It's 300 kilowatt at 690 volt AC and 350 kilowatt at 800 volt AC. And no derating up to 40 degrees C. It comes with fully skidded solution, AC combiner, medium voltage transformer, multiple communication platform. It has PLC communication, Ethernet, TCP/IP, and optional fiber optics communication. We'll cover a lot more details about this product in the next couple of slides. So this is Solis 250 to 350 kilowatt utility inverter introduction. This is the inverter in kind of details. We introduce here a little different version of this inverter using pigtails, where we combine two strings inside the inverter to each MPPT. So basically you have 12 MPPTs and 12 inputs coming in. This improves the wiring in a field where you just need to bring in 12 wires, positive, 12 negatives to the inverter, instead of 24 positive, 24 negatives to the inverter. It could be combined upstream with Y connectors, and basically with the single connection bring to the field. Additional improvement with the pigtails is there is a higher reliability of pigtails in terms of breaking the connector during commissioning, during O&M, and during replacement of the inverter sometimes. So that really advances the reliability of overall system, that if you break a connector, in most cases you need to RMA the inverter. In this case, you can just cut the wire, put a new connector in, and install the new connection without RMAing the inverter. So we believe that will enhance the reliability of this product over the years. Also, there is sometimes storms, wind storms coming in those sites, because most of them located in a desert, and when something hits those wires, could break those connectors. This additionally prevent this from happening in the future. As I mentioned, we have three flavors of this product: 250 kilowatt, 12 MPPT, 24 strings, 600 volt AC, and then 300 kilowatt, 12 MPPT, 24 strings, 690 volt AC. And the 350 kilowatt comes with 12 or 16 MPPTs, 24 or 32 strings, 800 volt AC. The key features of this product, it's a low startup voltage, 500 volt startup voltage. So your power harvesting, also wide tracking range. So your power harvesting could start early in the morning and will be late at night. So wide operating range. As I said in the previous slide, three different versions of power. No combiner box with MC4 connections. And no fusing required, so you can combine upstream the two strings and then run single connection. Y cable in the field, string combining, string monitoring, and remote local intelligent IV scan function. Remote firmware upgrade when connected to Solis Cloud. So we can control this inverter remotely, do remote settings, firmware updates, and even commissioning reports and so forth if it's connected to Solis Cloud. Power line communication, you can choose the different speed, baud rate speeds, 9600 to 115 to 200 baud rate, and then also Ethernet TCP/IP, RS-485, and fiber optics optional. Maximum input current per MPPT is 40 amps. So you can incorporate pretty much the latest 700 watt, even higher power modules with this inverter, and short circuit current rating 7 amps. So there is really no limitation for what kind of modules you could be connecting to this inverter, and as well as DC to AC ratio that you could be using with this inverter, because it will be limited basically only for the 7 amps short circuit current. It has a feature of data recording during write-through event. So in the event of a write-through, we record the event, and that data could be retrieved over the Modbus over the communication. It has integrated anti-PID and PID recovery. Anti-PID is during daytime, PID recovery is nighttime recovery. So both could be available. One need to be selected one at a time. Power response time, less than 60 milliseconds to power command for reactive and active power support. Night ward support, so you could have reactive power support at night. It is designed in NEMA 4X C5 enclosure, so could be in the most harsh environment condition installed by the sea or any other harsh environment locations. This shows the PLC communication. So basically you have one communication device per skid or per installation. It is has advantages for utility scale application because the communication done through power line and no copper wires are required. That also prevents lightning issues and other issues that could damage the communication devices in the field. Reduce construction costs and cables. It's rated 220 to 920 volt AC. So that way 800 volt device could be easily connected with the PLC communication. Up to 80 devices could be connected to a single PLC device. It's IP20 enclosure, RS-485, TCP/IP, Bluetooth connectivity for easy setup. So you can choose your communication through the Bluetooth and configuration of the PLC device through Bluetooth. External data locker can be connected to the third-party controller, and settable baud rate 9600 to 115 200 rate. With this solution, we also provide an AC combiner, which combines multiple inverters AC output to a single combined output. So it's basically 800 volts AC, 1000 volt rated output. The disconnect, and then it comes with 3 different fuse ratings, 1000 amp, 800 amp, and 630 amp. It's UL 1741 rated and certified with 4, 3, and 2 inverter system. 90-degree ratings for the terminals. So basically the wire, when you select per NEC, it's 90-degree terminal rating. It can combine 3 350 kilowatt inverter, 4 255, 4 185, and 8 125 inverters. So you could have multiple inverter combinations here with this enclosure, with this AC combiner. You can use up to 250 to 750 kc mil incoming cables, and outgoing cables could be 600 to 1000 kc mil. So it gives you a lot of flexibility on the cable sizes. It is UL NEMA 3R rated. And now we'll present the utility skid solution. So with this AC combiner and inverter, we also provide a skidded solution. So we provide the skid, 4.2 megawatt here shown a sample how a 4.2 megawatt skid could be connected as a single line So we have a 350 kilowatt inverter, 12 inverter connected together with 3 inverter per AC combiner, and then 4 AC combiners connected to a low voltage bus bar in a medium voltage station. You have surge protection on the low voltage side and fuse protection on the medium voltage side. It comes with a standard 5 kilowatt kVA auxiliary transformer with a 120 amp circuit breaker and optional 30 kVA transformer for trackers that is 480 volt rated. And also comes with a communication control that could be installed in the skid as well. Here's kind of the mechanical design of the skid. Like I mentioned, 4.2 megawatt. The transformer is rated 34.5 kV and 800 volts. On the low voltage side, it comes with different vector groups, DY1, DY11, and YG. So it could be connected to different utilities or interconnections. 30 kVA auxiliary transformer, 6 480 volt breakers with 20 amps ratings, and then standard 5 kVA transformer with 720 amp 16 amp breakers and GFDI receptacle. PLC communication integrated in the skid, so you don't need another enclosure. All the communication devices could be installed in that enclosure. Third-party SCADA located on the side externally could be also wired and connected in the skid. And then it comes, it fits in a 20-foot container, one skid, and 2 skids could fit in the 40-foot container. So you can save some costs by shipping those with a 2 skid per container. UL NEMA 3R enclosure for the skid, and low voltage cabinet, 30 kVA, 5 kVA, and communication equipment located in the low voltage cabinet, which is located kind of to the side of the low voltage cabinet. Those kind of the picture of this skid that shows the overall skid, the control panel, shows the low voltage cabinet with a circuit breaker and a disconnect. So kind of the actual finished product. We also provide for a smaller utility scale or for smaller projects, especially that require different interconnection voltages other than 34.5 kV. A smaller skid, 2.8 to 3.15 megawatt skids. It's similar design as the previous skid, where you can connect multiple 350 kilowatt inverter with AC combiner directly into the low voltage cabinet. That skid, it's 2.8 to 3.15. It starts at 12.47 up to 34.5 kV. So you could have different voltage, medium voltage combination on this particular skid. The auxiliary power equipment is the same, so 30 kVA transformer there, 5 kVA auxiliary transformer, PLC communication integrated as well in the skid, third-party SCADA racking, and you can see all the circuit breakers that are located in the low voltage cabinet, including the transformer. It fits in a 20-foot container. 3 of them could fit in the 40-foot container. So really could save a lot of costs on shipping this. And UL NEMA 3R enclosure. Low voltage cabinet has the 30 kVA, 5 kVA communication equipment. Now we'll turn into your questions and answer. And the idea is basically to educate and advise the audience on this product and how you can use this product in your upcoming utility scale and smaller commercial or maybe even community solar projects.
Great, Igor. Thank you for that technical description. So as everybody knows, when we sent out the invites, we asked everybody for some questions that they'd maybe like to get some answers for. So I have a list, and we're also, looking at the chat as well to see if there's any new questions. But let me just run through some of the questions that some people asked, and Igor, if you could answer them, that would be great. So the first question is, what do you feel the benefit of string inverters versus central for utility scale projects are?
Being in this industry and installing and commissioning central inverters for the past about 24 years, there are definitely a lot of benefit for string inverters versus central inverters. That starts from O&M support, goes with purchasing, system design, energy harvesting, commissioning, supply chain. So those are all the kind of highlighted benefit of this. So O&M cost, this string inverter model, it's replace compared to repair model, requires a lot lesser, I would say, training to replace the inverter, string inverter versus repairing the central inverter. I trained many field service engineers over the years repairing the central inverters, and it does take a high level, technical level expertise to repair those inverters, including Power One, including SunGrow. So those take really a lot of training, and those typically could be only performed by factory or regional field service engineers. So here with string inverters, you can replace the inverter by training somebody in a day or two that is O&M provider, and no original manufacturer required to be involved with this repair or replace scenario. There is really the spare parts list of the string inverters is only the inverter in most cases. Sometimes we recommend to have spare fans, but in general, just the inverter. Compared to spare parts that utility central inverter requires, there is a line of spare parts, starting with power modules, contactors, circuit breakers. I mean, there's at least 15 to 20 parts that you require to have in your stock in order to repair a central inverter in timely manner. Power harvesting also, we found that with multi-MPPT, you can get anywhere between 5 to 10% additional power harvesting, in addition to recognizing broken module, open fusing, soiling effect on the modules. So all those contributes to better O&M and more efficient O&M, and also give you a lot more power harvesting. I think for me, the biggest thing is it's actually a long-term issue with central inverter compared to string inverter. In long term, we right now facing a lot of repowering projects, and those are projects that are 8 to 10 years old, where the spare parts are no longer available and the inverters are no longer available to replace. So repowering of those older central inverters, and again, those are not that old, only maybe 8 to 12 years old, is required. Where with a string inverter, that could be easily replaced, and we've been doing this on commercial and residential for many years, replacing older inverters with the new inverters, because in most cases they are backward compatible. Like our 350 could replace our 255 models that are about 4 years now without any rewiring requirements. And the same goes for older models as well. So I think long term, when somebody looking in long term, that's for me, bankability wise, as a product bankability, number one reason to use string inverters compared to central inverters.
Great, Igor, thanks. Those are some good topics. You know, continuing on that theme, one of the questions we got were, why doesn't the U.S. build more utility sites with string inverters versus APAC or Europe? So what do you see as the obstacle for more growth in the United States? Because it seems the rest of the world understands the value.
Yeah, that's a very good question, Darren. So, and it's a challenge in US been for a while. I've been trying to have this conversation for the past, I would say, 5 6 years since I was working with Sangro. At the time, we offer both, and the advantages are clear, but a lot of time the cost was the main issue. The other thing is the know-how. So the central inverter installation being there for almost 20 years. So there is a lot of EPC know-how to install this and how to work. Where on the string inverters, it's still kind of learning curve, and I think that's where a lot of APCs uh, prefer to use central inverter. Although the cost used to be the number one, I would say, issue. Why? Right now, with the 350 kilowatt and with the balance of system that we propose here, where you don't need combiner boxes, you don't need to run BLA cables with fusing and so forth. Uh, uh, that balance of system, including the inverter, is compatible in cost wise with central inverters. So I believe this is a very strong argument here why in US we should start using and seeing more and more project using string inverters. Also, people start recognizing the fact that repowering is costly. They lose a lot of money on this. So I think there will be more push on investors to use string inverters because of those reasons that we mentioned earlier.
Okay, great. Thanks for that answer. So I wanted to touch on something you mentioned a little bit earlier. You said multiple MPPTs. So as we all know, string inverters have multiple MPPTs. Can you contrast the pros and the cons of that, and then some other options that we're going to be offering our customers in 2025 for in reference to MPPTs?
Yeah, so Solis Tech is stand that we do not dictate the market. We basically work with the market to see what is the requirement of the market. So we are planning to introduce a single MPPT inverter as well in 2025 that is rated about the same power rating as this 350 kilowatt rating inverter. But the some advantages of the multi MPPTs are basically a little bit better power harvesting than a single MPPT inverter on the string level. You do have two-stage conversion, so you do harvest power a little bit earlier and later compared to a single MPPT inverter, where it's only usually rated about 900 volts, so it harvests power just when the sun is kind of about 900 volts level. The disadvantage of multi-MPPT, it's more in a location where you locate the inverter compared to the medium voltage station. For with a single MPPT, you're able to locate the inverter close to the medium voltage station, kind of create your virtual central solution and have AC wires to be short runs with minimum losses on the AC side losses. Uh, the disadvantage, you need fusing. So you're introducing again fuses now, where with a multi-MPPT you don't need fusing. That's another point of failure that you might not recognize right away. If one fuse is blown, it sometimes might take 6 months to a year to find out that that fuse is blown. And then you need some kind of combiner. So either you use a BLA to combine it with the fusing to be externally run on the cables, or you need an DC combiner, which is additional cost, additional components, and additional wiring. So both solution to me, I think, are a very strong solution. Both have advantages and disadvantages, and I think it's depend on the application and preference. One could be used over the other. Again, the multi-MPPT disadvantage as far as AC wires, there is additional AC wire loss. There's minimum DC wire loss, but there is additional AC wire loss because most of the time the installation will be distributed architecture. This installation where the inverter will be installed in next to the string. So that's kind of some of the things. Although with the pigtail solution that we're providing, it could be installed as a virtual central, and because we're reducing the number of cables required to run from the string from, let's say, 48 cables per inverter to 24 cables now, that's something also could be considered as virtual centrals as well.
Okay, great, thanks. So we've got quite a diverse group. We've got EPCs, developers, we've got some utilities. So how would you help somebody design their first string utility scale site? What would they look for? How would they know if one of the projects in their pipeline could be a good candidate for doing string inverters, as most of the folks on the call probably have not done a project using string inverters? So can you help them maybe think what could be a good first project for them?
Yeah, so string inverters definitely have a huge benefit in topography. It depends on the topography of the site. So if it's a hilly topography, someplace in the East Coast, that really brings the advantage of the string inverters, where you don't have to have skids that are all the same sizes. You can optimize your land usage with string inverters a lot better than with the central inverters. The other thing to look at is what is the availability of the power that is required. So, for example, if the site required to have 99% availability, then central inverter is almost not a starter, because at this point, to have a 99% availability on central inverter will be very difficult to achieve. If your 4.6 megawatt skid goes down, it's a big percentage of your power goes down, and sometimes that could be a week, sometimes 2 weeks, depending on the failure. So that's kind of where the other definitely string inverter brings a big advantage there. And the third thing is warranty. So if the site needs to be 30-year warranted by the financial and has to be operated for 30 years, central inverter has been proven not able to survive this kind of 30-year warranty. So that's right away puts you into considering string inverters as the alternative solution for that. So those are kind of key points right away where you say, well, check. If those three things are checked, you definitely must use string inverters if you need all those things to be met. The rest is kind of basically at this point up to the developer and the EPC, what their experience is and how comfortable they are choosing one over the other. But yeah, I think for all those obvious reasons, string inverters bring a strong benefit in the next utility projects that are coming up.
No, that makes a lot of sense. I wanted to delve into something you said a little bit more, repowering. So in order, most of the folks on the call would love to get their plants to run for 30 or 35 years. So can you go into more detail? I know you mentioned it earlier, you showed some slides, but how does Solis and our string inverters enable them to repower for 30 years? Because, the voltages will change. So what exactly are we doing that they can have some confidence that, Solis will be able to support them as voltages change and output and current?
That's a good question. That's where I think we learn from, for example, commercial and industrial application, where we can repower just by simple replacement, one-to-one replacement in most cases, because in those conditions, the grid didn't change, so it was 480. We have 480, and the input voltage didn't change, 1,000 volt. It's still 1,000 volt. With the utility scale, even if we in the future go, for example, 2,000 volt, we can always replace a 1,500 volt inverter with a 2,000 volt inverter. That's not so much of an issue. Output voltage, as you've seen, we introducing with this model 600 volt, which we support in older generation, to 690 volt, also older generation. This particular model is designed for repowering actually application, and 800 volt generation. So it's easy to in the future to have multiple AC output voltage and be able compatible with DC input voltages for future projects that are using string inverters. So for like we have a 1 gigawatt installation in China with our string inverters, 230 kilowatt string inverters. We can simply replace that same 230 kilowatt with this 350 kilowatt without changing a single wire. So that's basically the advantage of using string inverters that are backward compatible. Over this, we have also multiple inverter providers that are pretty much backward compatible with each other. So there are multiple sources. So if one source goes away, and even if it's a good bankable source today, like what I used to work for ABB was a good, strong ABB source. Schneider, the same thing. A&E, the same thing. Those are all bankable, strong companies that decided one day to leave renewable and to move to their more competent markets. People got stranded with no support. So that's where multi-sources also very critical to have on the string inverters. So on the string inverters, there are definitely multiple sources that are competing in these power levels, and they have solution in these power levels.
Great, thank you. So again, just for the folks on the call, at Solis, we believe we can power your plants for at least 30 years or longer with very minimal effort on your part. One of the other questions, if we get into a little more technical on the inverters, so what is the DC-AC ratio of string inverters? Is it similar to central inverters? Can I AC couple storage? Are there any limitations there? How do I design if I'm going to add storage to my solar project?
Yeah, so the string inverter, the 350, it's limited basically by the short circuit current, input short circuit current of this inverter, which is rated 7 amps. So basically the DC to AC ratio, that's the limitation. You cannot exceed the short circuit current rating of this inverter under worst case thermal condition, which is usually the higher temperature. That's where the short circuit current will be the highest. Under that condition, you should always stay below 7 amps. As long as you do that, that is the limit of the DC to AC ratio, which in conversion usually works to be around 2 to 1. So actually DC to AC ratio of 2 to 1, it's possible with this type of inverter.
Okay. And another question, more on the technical side, is how many of these inverters can you parallel together? And so what does our virtual central inverter look like, and what's the maximum number?
So the limitation is usually not so much the inverter, but the skid. So usually in US, pet mount skids are most common, most cost effective skids compared to like European skid. They use the medium voltage switchgear, so their skid could get larger because they use the medium voltage skid switchgear. But in US, pet mount is the most cost effective solution, and that solution usually limits the skid to 5 megawatt maximum. So that's usually the limitation. So I would say 12 to 16 inverters maximum. From the inverter itself, we can connect up to 30 inverters in parallel, but because of the skid limitation, usually more than 16 would not be practical.
Okay. And just moving further along on some of the other questions. So I know you talked a little bit about the O&M, but give me your thoughts on the break-fix model for string inverters and your availability. So, what are the real advantages over central, and how do people monetize that from a project standpoint?
So as I mentioned earlier, it's replace versus repair type of model. And replacement on the inverter can be done and accomplished by a field service engineer level 1, the most basic level engineer level 1, what we call it, where on the central, you require usually to repair an inverter level 3, usually most experienced type of field service engineer require. Training for somebody on an O&M team to replace the inverter, I would say, would not take more than 1 day, maybe 2 days if we need to train them how to do firmware updates, which again could be done remotely using Solis Cloud, but also could be done locally using local USB connection and update the firmware. So that totally could take up to 2 days of training. After that, that person could become an expert of replacement of the inverters in the field, and that way it becomes very easy for the O&M team to maintain those sites at the highest performing levels and up to, let's say, 99% availability and even sometimes higher.
Okay, good, thanks. One other thought. So what services does Solis offer in helping someone design their first string inverter project? So I know you have an application team. What kind of support do you offer to give them the ability to determine if their project would be a good fit?
Yeah, well, we're not engineering on record, but we are working with engineering on record on recommendations of how to size the inverter, sometimes also the location, where to put the best practice to put it. Depend on the site, we will evaluate if it makes sense to do virtual central or distributed architecture. So we do have PVC's expertise, so we can provide some guidance especially with multi-MPPT, sometimes if the strings are not well balanced or balanced identically, sometimes could be coming some issues in PVC's modeling this, so we can provide our expertise or advice how to model the multi-MPPT inverter in PVCs. So those are all the different things we can advise. How to evaluate the site in terms of the grid condition, the point of interconnection, short circuit current ratio of the interconnections, whether it's suitable for the inverter. Right now, the 350 kilowatt inverter is able to operate under very poor short circuit current condition, as low as 1.2 short circuit current ratio, which is pretty impressive compared to the previous models that would not be stable at operation of 2.5 and below. So at 2.5 would be stable, but at 2 there would be some questions already. So this one, it's a lot more stable, but we can assist the developers with all this questions that are related to point of interconnection, PSCAD modeling, PVSys modeling, all this PSSE modeling, all those support is available with my team and myself.
Great, thank you. So just opening it up to the folks on the webinar, are there any other questions that somebody would like to put into the chat? Or if not, Igor, I would say, what are your final thoughts, and summarize kind of why you think string inverters are the future of utility scale projects in the United States?
No, I think we covered it pretty extensively in this topic. You had a very good questions there asked from the audience, and the string inverter definitely is the future of the utility scale projects that will be developed in the next several years for the various reasons that we discussed, for the reliabilities, for manufacturability of the product. All of those products are built on fully automated line, as you showed early in the introduction, that done complete testing, complete burning on every model. So for all those reasons, I believe, coming from the central inverter world and being in the central inverter world for so many years, I believe string inverters will bring a huge benefits in the future for the developers, for the O&M, and eventually EPCs would like to install the string inverters compared to central inverters better as well. So.
Right, great, thank you. So one question that did come up that we haven't really highlighted, the 350 kilowatt inverter will be released in August, towards the end of August of 2024. So we are presently in the process of taking orders for deliveries in Q4 of this year. So for anybody on this call, on the webinar, that would like to get more information, a proposal, have Igor's team help you design it, please feel free to reach out to Igor or myself. We want to thank everybody for spending approximately an hour with us. We're almost at the top of it now, so thank you again. And our emails will be attached to the last slide, so feel free to reach out to either of us if you have any questions, and we thank you again for spending an hour with us.
Yeah, thank you very much for your attention, and hope you'll join us on upcoming additional webinars from Solis.